Hello everybody. Today I will be talking about an experience I had 36 years ago. I was privileged to be part of a unique experiment. Right in front of me, what I saw happening was a very clear measurement of what people call overunity. And when I saw that, I'd already been looking in that direction, mind you, but when I saw that happen, I was totally hooked. I cannot let it go. So, I am David Shipley Alexander. Welcome to my Infinite Energy series on YouTube, and this is video number 9. I call it the graphite rod experiment, or overunity demonstrated. The reference below, which is from a NASA publication describing a breakthrough propulsion physics workshop where I presented the overview of the experiment I'll be talking about as a poster paper. And the contact information as part of that reference is totally obsolete. I'm no longer a part of that organization. So the experiment in question occurred in 1981. I was part of a research group where we were characterizing a source of a very intense radiant light and heat. Basically, it was just a piece of graphite. Now this is cardboard painted black, but it looked like this. It was wider at the ends. We were providing a very high electric current out of heavy-duty truck batteries, and we measured the voltage from end to end. The voltage dropped through the graphite, and then we were measuring the current through the graphite and the voltage drop across the graphite. The voltage and current were being very accurately measured, and with the DC circuit that this was, the product of voltage and current is power, electric power. The radiant, you can call it heat, but it was really incandescent, it was light and heat. That power radiated from the graphite was measured with what's called a calorimeter. Measures power, radiated power per area. Multiplied times the area of the graphite gives the total power radiated. And that calorimeter was very accurately calibrated with a standard calorimeter at what was then called the National Bureau of Standards. It's now called NIST. The experiment ran about 10 seconds because the voltage in the battery dropped. And what makes this even more interesting, which led to the particular outcome, was that another group at the same lab had previously done a very similar measurement with graphite, but what they found was they were consistently seeing overunity, more output than input, and they made the assumption that this was due to the graphite burning in air. Well, graphite is a form of carbon. You get carbon that hot, it very definitely burns in air. But I decided to add one thing to the experiment, and that was to weigh the graphite before and after. That let me know how much combustion a mass of carbon that was burning, and then I could just look in a reference book and find out how much that was contributing to the radiated power. The various data, voltage, current, radiated power, and so forth, were stored in a state-of-the-art 1981 computer for analysis and printout. And the experimental results were very interesting. For one experiment, the data looked like these. The output power is near 25 kilowatts. That's a radiated power. The electric input power near 17 kilowatts. But the combustion power was actually small. It was only less than 1 kilowatt. When you divide the output power by the two input powers, it's a factor, it was 1.41. 141%, or 41% of what was accurately measured over unity. Now the reaction of the lab manager was most interesting. He said to me, "You have obviously made a mistake." And he said that even before he looked at the data. Why would he do that? In the world of electricity and magnetism, and in fact other energy measurements, the people in academia and industry always assume that the inputs equal the outputs. But I can tell you from 40 years research into these types of situations, especially when electricity and magnetism are involved, it's not always necessarily an accurate statement that the output equals the input. So, in that case, one would ask, well, where does the extra power come from? And the answer is, after countless hours thinking about the same experiment, the answer is, I don't know. But if you have comments on this or ideas, there's a place below to provide that. And thank you for your attention. The thumbs up is nice. And if you subscribe, YouTube will tell you when I put up the next video. So stay tuned and find out what that will be. Until then, I am David Shipley Alexander.